welcome everybody to Azure Synapse Analytics, SQL Pools, Performance Tips and Tricks. So we have 45 minutes today, so hopefully we'll have time to cover everything. And if not, you'll get something for improving the performance of your SQL pools. Thank you to the organizers actually for putting this event together. It always takes a lot of time actually and personal time, especially to organize an event, to align the speakers, to spend the Saturday actually learning about Azure Synapse Analytics, making sure that everything goes smooth. I'm David Alzamendi. I'm based in Brisbane, Australia, which means that right now it's midnight. So we made it. I made it to Sunday, right? So after this session, I potentially have a shower and I'll go to sleep. So if you have any questions, feel free to reach out at my email address or blog. But you know what? Let's get started. Let's go and improve the performance of our SQL pools. Let's set up the scenario for today because Azure Synapse Analytics, as you know, is an ecosystem where we can perform big data workloads, data warehousing workloads, machine learning workloads. Today, we're going to be looking at one of the most mature services within the Azure Synapse Analytics ecosystems, and that's the dedicated SQL pool, the provisioned dedicated SQL pool. This is a service that has been around for more than 10 years already. It has been rebranded with different names, and now it's the dedicated SQL pool. We'll cover potentially, depending on the time, between 8 and 9 performance tips and tricks. So let's get started. The first one actually is about data skew. When with dedicated SQL pools, we need to understand we have different types of tables. So we have the Columnstore tables that are distributed based on a specific column. That means that information is distributed using a specific column that we can select. We have as well the Columnstore. All of them are Columnstore tables, these ones. They're distributed on round robin. That means that they are not distributed on any specific column, and they'll be distributed evenly across the storage. Then we have the replicate tables, where the information is going to be replicated across each one of the compute nodes that we have in the dedicated SQL pool. Just a quick summary, and we reviewed this in one of the previous sessions, that there is always we have a control node, and then we have the compute nodes, and the control node commands and send orders to the compute nodes. And you could potentially have one compute node or two compute nodes, many compute nodes. And then, of course, we'll have the traditional heap tables. What I think is really important to understand when looking at, if it's a hash distributed table or a round robin table or replicate table, is that Azure Synapse Analytics dedicated SQL pools store the information across 60 distributions. 60 is the magic number for today. 60 is the number that we need to keep in mind for the session today. 60 distributions in the storage. And data skew means that the information is not evenly distributed across those 60 distributions. Really important. So on top of that, now that you have an idea on what data skew is and the different type of tables, you also need to understand that depending on the performance level that you're working with your dedicated SQL pool, you'll get a different number of compute nodes. As you assign more data warehouse units, the number of compute nodes is going to increase as well. That means that when you have one compute node, so that compute node is working with the 60 distributions. But when you have two compute nodes, so those 60 distributions, they are split across the two compute nodes. And as the number of data warehouse units goes up, the number of compute nodes goes up. And that means that potentially by having more compute nodes, you can enable the parallelism when working with the storage. It could be for inserting new information, for reading information, but the less number of distributions are assigned to each compute node, the faster the platform is going to perform. The information is not distributed evenly, and we're going to see that with a few examples. That means that some compute nodes, they'll be working harder than other compute nodes. Here you have an example actually, and we'll share the queries and the resources, but you can see here how this table has up to the data, table skew percentage of 100%. So that's not good. That means that it means that some of the distributions of those 60 distributions, they don't have any rows. And what we want to do is to get to a point that the number of rows across each one of the distributions is quite similar. And you can easily achieve this by using the round-robin table that we saw before, because that one is going to distribute the information evenly across the 60 distributions. But that also comes with some challenges in the long term that we're going to revisit today. So let's go and pick an example. This Power BI window here, you can see here we have a table. The table has many rows, just one table, and we only have one compute node. We have at the bottom 60 distributions, and the ideal number of rows for each one of those distributions is this line over here. So that means that there are many distributions right now where the information is quite low. The number of rows in those distributions is quite low. And we also have some of the distributions that have many rows. You can see that distribution over here has around 50 million rows, while the one at the bottom might have 1 million rows. So what it means is that when working with one compute node, it might not look like a big challenge, right? Because just the compute node will look at the 60 distributions and that's all. But what happens in the moment that we have two compute nodes, right? So imagine now that we're running the Data Warehouse Unit 1000, so therefore we have two compute nodes. So that means that one of the compute nodes, compute node number 1, is going to be querying or working with 74% of the total number of rows. And compute node number 2 will be working with 25% of the total number of rows. Now you can see how our massively parallel processing system, even that it can enable parallel workloads across compute nodes, if we make one compute node working harder than the other one, so that will cause some bottlenecks. And as we assign more compute nodes, you'll see that the challenge is going to persist. So we mentioned, okay, let's solve this. Let's do round-robin distribution, right? So we create the Columnstore table. We say hash distributed by round-robin, and we solve the problem, right? That could be the scenario actually for some cases, but not for all of them. And we're going to look at that in the next topic. Okay, so what do you need to do to monitor data skew? Is we share this with the resources. Well, let me browse over here. What you want to do is as easy as being proactive. And what does it mean to be proactive? So don't wait for a problem to happen for you to spend time solving it. So this query here, this is provided by Microsoft, and I build always when I work with Synapse, I build a Power BI report that displays the data skew across the different tables. And what you see here, the query returns if there is data skew across the distribution. Same query that you saw before. And what this means, so if we're looking at the report, or we even define an alert when the data skew percentage goes over a specific threshold, we can go and mitigate any potential challenges near in the future. And if we don't need to do anything, at least we're aware about the state of our data skew in our tables. So really important, data skew is one of the things actually that they affect the most the performance in dedicated SQL pools with our next topic, that is the shuffle movement operations. Now, imagine same scenario. So we decided that we want to use round robin for all our tables because we don't want to have data skew, right? But by doing that, that means that when we want to join the information between two different tables, that have to go to the 60 distributions and try to find records in all the distributions. For example, find record in distribution number 1 and join that record with a record in distribution number 59. So shuffle movement operations are something that we want to keep in mind. So in this example, we're going to go to a real example, but you can see, imagine that we want we have a table, the table sales that is distributed based on product ID, and then we have the orders table that is distributed as well in using product ID. So that will be the ideal scenario. I think this is incorrect. Okay, so this one, imagine that this one here is distributed using round robin. So that means that to find product ID 54 of orders, and we are looking at doing a join between those two tables. You can see it here. So we have to go to search 54 in the other 60 distributions in the sales table. So that's going to cause a shuffle data movement operation that we want to avoid. What I've seen during the past 5 years is that when a query in Synapse Analytics takes 4 hours to be processed, is mainly 90% of the cases, if not all of them, is cost of a shuffle data movement operation. Let's go and see a real example. Let me bring Management Studio. So here I have, let me zoom in. So we're here. So I have 3 tables. So this table over here is using round robin distribution. Then we have 2 tables that are using date key as the hash distributed column. So now I'm going to execute a join between the round robin table and the hash distributed table. Really important point, actually, if you're not using labels, I do encourage you to use labels in your store pros everywhere. It's really easy for you to do performance analysis if you're using them. So let's go and run this query over here. And at the same time, so we're going to track that query. So let's give some time to kick off. Still running the cache move. So let me just not waste our time with that. Run it over here. I still need to run. I will have a tip later that is about caching. So right now, this result set it was coming from caching. So we need to make sure that we drop the cache and we can run the real query. But in a nutshell, so what we're trying to do, the first query is going to join a round robin table with a hash distributed table. And the second query is going to join the 2 tables over here that are using the same key, are using the date key as the hash distributed column. So now we can go back and run this one over here. And it still goes too fast for. Okay, let's go and run the second one. And I'll show you what we're trying to achieve here. So now we pick up that query. You can see that I'll pick up the ID and I'll show you the steps. You can see that this is the steps that we're going to execute for that specific query. So remember, this query is just joining two tables that are using the same hash distributed key. And as far as we know, it has already finished. So there is not any other step. So this is the only step that we have to execute at the compute node level is this one for here. Now let's try to see if we can run the round robin with this one here, or we can try to use a different column. Unit cost, unit in. I will have to create definitely a different query plan. What happens when you run real demos table? Okay, now that's created a new query plan, no caching. Now I can go back, pick up our query. Now you're going to see that in this case, because we're joining two tables with different distribution keys, so this is going to cause a shuffle movement operation. The bigger your system is, the bigger the tables are, and you're trying to join two tables that have different distribution keys, the more challenges you're going to have with the shuffle movement operation. So what can you do to avoid this to happen? So first of all, don't try to solve a query problem to change your underlying table's structure. So that's the first thing. Don't try to change your underlying table structure just to fix one query, because if you try to do that, you might fix that query, but you might be affecting the performance of other 100 queries. So be aware of that. So when you are bringing data, when you are inserting data in your data warehouse, I do suggest before inserting table from table A into table B, and let's say that table I and table B, they have different distribution keys, I would suggest to create a table as a select with the same distribution key as your destination table before you insert the records. And the second thing, when you are reading the information, the best thing to do about that actually is to start thinking about caching, materialized views, and we're going to see a few of the things, or even to persist. If you have a view that or a query that you have to persist as a table, I do suggest go and do that. Shuffle data movements operations, so they can make your query go from 1 hour to 10 hours. That's the real world. Replicated tables. We mentioned this before. When you create a replicate table, that creates a replica of the same information across all the compute nodes, which is great for lookups and small tables, and even sometimes in a few cases, you might use a big table as a replicate table to overcome some performance issues in the query side. But what most people don't know actually, that for you to kick off the replication of to replicate the information across the compute nodes, is that you need to select the information of that table. So let's put it this way. So we're going to look at a specific example, so it's easier for us to track it. So let's go and look at this table here. So this table right now is empty, and we're going to insert let me try to make this bigger. Okay, and we're going to insert just one row in the table. So now we have inserted the row. I'm not going to query the table. So there is a dynamic view that you can use actually to understand if that data has been replicated across the compute nodes. And as you can see, the state for our dim product replicate table say this one from here, it's not ready. This means that the information is not replicated across the compute nodes. So in order for us to kick off that replication, we have to select or query the information in that table. So if I do this, we go back to this state. You can see that now the information is available for the engine and the compute nodes to use it. So really important. So if you are working with replicate tables and you manipulate information, could be an insert, delete, truncate, make sure that after that you do a select top one to kick off the replication. The same if we insert another product, so the same will happen. You can see that it becomes not ready and we have to select the information from that table. Yeah, I know, select top one, maybe not the best approach, but this is how it is. So if you, and so far we've been doing this for so many years that it doesn't really affect the performance of any processes of Synapse or anything like that. Just run a select top one and you'll mitigate that challenge. Replicate tables. The next one is statistics. So statistics, many years ago, they were not created automatically or maintained in Synapse Analytics. It was quite of a little bit. We have to build the store procs to create the statistics or do it manually as part of the processes. So now Synapse Analytics creates statistics for you automatically. So that means that when you have the auto-creation of stats enabled in Synapse Analytics, and now it is enabled by default. That means that if you create a dedicated SQL pool today, the creation of stats automatically is enabled. That was not the same case if you created the SQL pool 3 years ago. You have to go and enable it. What you have to take into account is that Synapse creates the stats for you, but it doesn't maintain the stats for you automatically. So we need to look after them. And the best thing to do, actually, I do suggest to update the stats is to just write this command, update the statistics and the name of the table. That will update any statistics that you have in that table. So that means that you don't need to go one statistic at a time and update it. If you write this command, all the stats will be updated as part of this command line. So what do you need to do? So every time, again, that you work with a table, so when you insert information, update information, or delete information, make sure that you update the stats after working with a table. On top of that, I do recommend to include a daily maintenance for statistics that the variation between the actual number of rows and the stats number of rows is quite different, and a weekly maintenance store proc that runs and make sure that update stats that are old. Okay, let's go and have a look at the stats. So let me bring one of the scripts. All right. Let's pick up this one and this one. And again, scripts that are available in the Microsoft documentation. I'll show the links at the end of the presentation as well. But what you want to make sure is that the stats are up to date. And you can see here in our case, so we're looking at these columns here. So you want to make sure that the current number of rows and the stats number of rows is the same, because this has been quite important since the creation of SQL Server many years ago. So if the number of rows that you have in the stats, and we can easily look at an example. So let's go and truncate the table in this table. Truncate table. the view accounts. Let's pick up that one. If the stats are incorrect, the query engine that is creating the query plan will not have all the information that it needs. So the information is not going to be correct. Therefore, your query plan might not be correct. Therefore, the performance of the query is going to be affected. So let's go and look at this account table right now. You can see that in the stats, it still believes that for the dimension accounts, we have 1,000 rows. The reality is that we don't have any rows. Therefore, the deviation between current number of rows and the actual number, the current number of rows and the stat rows is incorrect. So what you need to do is to update statistics for that specific table. Now we run this command. And we execute this query again. You'll see that again, so dim accounts. So it says stats row 1 row and actual number of rows 0. Could be a problem with the script, but definitely this is going to be better for the query engine when it's creating the query plan. So therefore, it's not going to affect the queries of our users. So stats again, and then you can monitor. We'll have to jump back to Synapse as well. I just closed it. So stats, keep it on front of mind. So they're created automatically, but you have to maintain them on a daily basis, on a weekly basis, and as well as part of your store procs and daily loads. Really important. So don't wait for the daily process to kick in to do the work for you. It's a good practice for you to update the stats as you work with information. Test to close everything. So let's go and move on. Number 5, external tables. So couple of years ago only, we had to create external tables in dedicated SQL pools. We had to write a lot of code, so which it was a pain. It was a pain to create an external table. And remember, external table is like it's a pointer to a different place. You can create an external table that is pointing to a specific folder or file within your Azure storage account or Azure data lake. By creating that external table, it allows you to query the information from the data lake without moving the information within your dedicated SQL pool. Same experience that we have with serverless in Azure Synapse Analytics. But now Microsoft has done all the work for us. So we can go and create external tables without writing any line of codes. And I'll show you how to do that. Many of you, you've seen this actually in the serverless offering, but today we're going to do it in the dedicated SQL pool option. So I'll pick up just one file over here. So let's say business entity. So right now, as we do with serverless option, we can go on new SQL script, create external table. We defined, I think maximum or minimum for Bakar. And then we specify the name, and we'll get the code. But instead of executing the code in the serverless option, so let's say that this is business entity test. I'm going to get this. I don't want this to go automatically. I could potentially change it here because I like to see the code. I'm going to open the script. And now I'm going to change this from the serverless option to my dedicated SQL pool. I'm going to write this command, execute this bit. And in the meantime, so we can either navigate to our SQL pool using the web browser experience. So external tables, and you can see that we have the external table here already. And if I go back to Management Studio, we look at or Azure Data Studio or your client tool of choice. So now we look over here. So you can see that now we have our external table, and we can start using the information without moving the information to the Synapse Analytics. So why this is so important? Because sometimes you just don't want to move the information to Synapse Analytics, or sometimes you're doing troubleshooting of a file from 2 years ago. So having this flexibility, it does give you a lot of opportunities. Remember that. And the other thing, for those one working with Azure Data Factory or Synapse pipelines, is that remember that any copy activity in your Synapse pipelines, so this copy activity, that is, let's say, moving the information from data lake to the dedicated SQL pool, is going to be 100 more times expensive than just writing a store block in the dedicated SQL pool that works with this external table. So that will certainly reduce the cost heavily if you are using the copy activity in Data Factory or Synapse pipelines. So something to take into account. This ongoing cost here is not for managed VNet or managed networks. This is just without the managed network capability, but it's something that I do recommend to go and have a look. And look, now we can create external tables, not only in serverless, but in dedicated SQL pools and start doing a lot of things. So I think the opportunities are endless on that case. Let's move to number 6, caching. So caching was a feature that was released around 1 year ago. I might be wrong, but it's less than 2 years, I believe. And it allows you to cache queries from your users, or even queries that you need for your data movement process that you run on a daily basis. Now, you have to enable caching. So it is not enabled by default. You have to enable it. So let's go and have a quick look at it. I'll bring Synapse one more time. Pick up the caching option. Thank you for your comments, Sarah. Okay, so first of all, you have to enable caching. So make sure you go and enable it. It's not enabled by default, as far as I know. You can go and have a quick look in this database here. Make sure that when querying this information, sometimes I've seen that the information in the master database is different from the information in the user database. So make sure that you're in the user database, and you can see that my resource set caching is enabled for data warehouse. So let's go and have a look at this table from here. So let me see, first of all, if I have any rows. I have this row here. And now I'm going to look at the query steps. And what I'm looking here is that we haven't hit the cache. If this was a 1, it means that we hit the cache. So I'm going to execute the same query one more time. And we're going to look at this. And now you can see that my last query is coming from. Not only that, is that if I look at where the information is coming from, so that means that if I pick up this, let's pick up this one. First one, the one that is not from the cache, and we look at the steps. So you can see that this goes from control node, give me the information, computer node, and computer node says, hey, here you go. Here you have the information. Now let's look at the information that is coming from cache. So pick up the ID. And in here, you'll see that it didn't go to the compute node. So where is the information coming from? So you can see if I look at the query, copy the command, and I paste this over here, that the information is coming from cache. Amazing feature. This feature is just, it is so amazing. Yeah, it does have some limitations here and there, but hey, look, when this came out, I was thinking this is life-changing for those one working with Synapse Analytics. Really important to take into account. You can disable caching for a session. The cache might become unavailable. So if I insert a new row and I query the table, because I have added one row, so that means that the underlying data has changed. So you'll see that now we haven't hit the cache. So when the underlying data changes, you won't be able to hit the cache. So the cache needs to be refreshed. But if I query the same table again, and we look at cache, now you can see again that this is coming from the cache. So my recommendations with this one, first of all, cache frequently asked queries. That's really important to help your users and overnight or daily processes. The second one, so when you pause the dedicated SQL pool, the cache is still there. So that means that you can cache information by using a higher service level. So that means that when you're running your daily process, right, that loads information, you assign more data warehouse units, more compute nodes. So that's the moment for you to cache information. Then you decrease the service level. That means that you have less data warehouse units. You pause the dedicated SQL pool. It will happen eventually when you restart the dedicated SQL pool, but the cache will still be there. Really, really important. That I think this last one is great as well. Columnstore indices. So this is more like an informative item, I believe. So we'll also have 5 minutes to go. But what I want to say, like Synapse Analytics, dedicated SQL pools, they are using Columnstore indices by default. So that means that when you create the tables that you saw before, when you create the round robin table, the hash distributed table, it's a Columnstore index table by default. That information is going to be allocated in row groups, and then it's going to be compressed and moved to the Columnstore index. So that one, this feature, it makes any data analytics workload extremely fast. So because the compression is up to 10 times, that means that it has to work with less volume of information, and processes and memory are way faster than IOPS and storage. So this is really important. Why you need to see, and you see this, because remember that you still have 60 logical distributions, and remember, so maximum up to 1 million rows, right? And we have 60 logical distributions. So remember that magic number for today, 60. And so that means that 60 logical distributions means that ideally you need to have big tables to have Columnstore indices, and not even think about partitioning tables. So if you start partitioning tables plus the 60 distributions, that's many rows. So be careful if you start partitioning your tables and you don't have enough number of rows, because that means the row groups are going to be quite low. So what you need to do, and we'll go through this quite quickly, but you need to monitor those row groups. The closer to 1 million, the better. Make sure that you still need to maintain your Columnstore indices. Yes, you need to reorganize them and rebuild them. I'm going to show you 3 examples for Columnstore indices. We'll wrap up with this one potentially, so we don't run out of time. Columnstore indices. So one will think, right? So I'm going to recreate this table here. Just a dummy table. So I'll truncate the information that will do. I make this bigger for us. So you'll say, okay, yeah, all the tables are Columnstore, right? But the information is not Columnstore by default. I'll show you why. So each row group is expecting to have a minimum number of 104,000 rows before it gets compressed. So I'm going to insert this information. So I'm inserting 5 million rows in this table. This will take around 18 seconds. And we're going to, after that, we're going to monitor the row groups, the state of those Columnstore indices for that table. So now we monitor those row groups, and you can see the state of the row groups for that table. They're open. Open means not compressed. Open means it's not yet Columnstore index, right? So now you see the 60 distributions as well here. So what does it make you think? So first of all, if you're inserting information and you want this to go directly to the Columnstore index, it has to be more than 102,000 rows per row group. So really important. Can I close row groups with less than 100,000 rows? Yes, you can, but the closest to 1 million rows, the more effective for the engine. So I'm going to close the row groups. So let me show you how you can close it. So pick up here I guess this is the index name. Hopefully it did the magic. So now you can run this reorganize, and this is going to close the groups for us. So that means that if now I go up, I go here and monitor the state of those Columnstore indices. So that means that now they are compressed. So now it is stored in a column format. Now it's compressed. Now we're taking advantage of that. But what happens when you add more rows? So let's say that we want to add another few rows. So now we're adding only 600,000 rows, and we monitor that. And now we have, you can see here we have, first of all, we have 60 distributions where the delta, so it is open, it is in a delta store, so it is not compressed. And if I scroll down, I still have the compressed distributions. So that means that the number of row groups, I can still go and close those 60 ones. I can go and close them. And I monitor that. And now we have 120 row groups compressed. So, but this is not effective. First of all, you can see the number of rows. Tombstone means that they're going to be deleted, right? But we have 60 over here. And if I scroll down, 60 over there, so 120, so it's not as effective. So what you can do is to rebuild the whole index for the table. So if you rebuild the index, that is going to put the 120, is going to try to simplify that to only 60 row groups. So now that we have compressed that by rebuilding the index, now we have only 60 here. So again, important. So I've seen many organizations that they are not looking at the reorganizing, rebuilding, looking at the Columnstore indices, something that you have to take into account. makes a huge difference as well to be on top of these capabilities. I do recommend to go and look at that. Again, if you insert more than 102,000 rows per row group, that will go immediately to compressed without going through the delta. And with that, I think we got to the end. So if you have any questions, just send me an email, a chat. I know there is a lot of information shared here today. We could have a second session near in the future, but yeah, don't feel afraid to go and take advantage of these capabilities that we've seen today, up to Columnstore indices, and a few tips and tricks for you and to improve the performance and not to have any more problems. So I'll hand it over to the MC for today.